All right, so get ready because today we're going to dive deep into something pretty wild, something called Titans.
Titans.
Yeah, Titans. It's a whole new kind of neural network architecture, and people are really starting to pay attention.
Interesting. I haven't heard of that one before.
Well, we're going to break it all down, figure out what makes them tick, and why everyone's making such a fuss.
Sounds good to me.
So we're basing this deep dive on a research paper. It's called Titans, Learning to Memorize at Test Time.
Learning to memorize, huh? That's a new one. Usually we're trying to get these models to learn and generalize.
Right, exactly. But that's what makes this so interesting. The idea is that these titans are tackling one of the biggest challenges in AI right now.
Which is?
How to handle massive amounts of information, like really huge data sets, without completely falling apart.
Ah, yeah, I see where you're going with this.
Oh.
That's a problem that's been plaguing even the most advanced models out there.
Exactly. Like transformers, for example.
Right, transformers. They're incredibly powerful, but they do have a weakness.
Yeah, they struggle when they have to deal with super long sequences of data. Like imagine trying to understand an entire book all at once.
Oof, yeah, that's a lot to keep track of. Even for a human, that's a tough one.
Exactly. And for a transformer, it becomes a real bottleneck.
It all comes down to how they process information. Their attention mechanism, which is usually their superpower, becomes super inefficient as the amount of data grows.
So it's like trying to solve a giant puzzle, but you can only see a tiny section at a time.
Yeah, you might be able to figure out some small patterns, but the big picture, the overall meaning, it just stays hidden.
And that's a huge problem for tasks like language modeling, where the context, the entire text, can be incredibly long.
Absolutely. And researchers have been trying to address this issue for a while now.
Yeah, didn't they come up with something called linear transformers to try and fix that?
They did, and it was a good step forward. They managed to make the processing much more efficient.
But there's always a trade-off, right?
Always. In this case, they had to sacrifice some of the power and flexibility that made transformers so successful in the first place.
So it's like choosing between a super fast sports car that can only fit two people and a minivan that can fit the whole family but is a lot slower.
Huh, I like that analogy.
Yeah.
And that brings us to what makes Titans so unique. The researchers behind them decided to view neural networks from a completely new perspective.
A new perspective. Tell me more.
They call it the memory perspective. Basically, they started thinking about how different types of neural networks have different ways of storing and retrieving information.
Hold on. Are you saying different neural networks have different memory systems?
That's exactly it. It's like how different animals have evolved different ways to remember things.
Okay, I'm intrigued. Give me an example.
Well, take simple RNNs with their hidden state. They're kind of like, let's say, a goldfish.
I go with that.
Yeah, a goldfish. They have a very basic instinctual memory. They react to the present based on a very limited set of past experiences.
So they're constantly forgetting what happened a few seconds ago.
Pretty much. Now compare that to transformers with their attention mechanism. They're more like, say, elephants. They have this remarkable capacity to remember a much wider range of past experiences.
But even elephants have their limits, right?
Exactly. And then there's linear transformers.
Where do they fit into this animal kingdom of memory?
Maybe they're like squirrels. They're great at stashing away bits of information very efficiently, but they can only hold so much in their mental cheek pouches.
Okay, I'm loving these analogies. So where do titans fit into all of this? What makes their memory system so special?
Well, I'd say titans are more like those birds that can remember the exact location of thousands of hidden seeds.
Wow, that's impressive.
They have this incredible ability to selectively store and retrieve vast amounts of information, even over very long periods.
That's amazing. But how do they decide what to remember and what to forget? Do they have some kind of super-powered neural filing cabinet?
That's where things get really interesting. The secret weapon of titans is this thing called a neural long-term memory module.
Neural long-term memory.
Yeah, and the way it works is actually inspired by how our own human brains form memories.
Hold on, are you saying that titans are learning to remember like humans?
In a way, yeah. Think about it. When something surprising or unexpected happens, it tends to stick in our minds much longer than everyday stuff.
That's true. Like, I'm definitely going to remember this conversation about AI memory systems for a lot longer than what I had for breakfast this morning.
Exactly. And Titans tap into that same principle. They've been designed to measure surprise by analyzing the incoming data and then prioritize storing those surprising or unexpected elements.
So they're learning to filter out the noise and focus on the signal, the really important stuff.
You got it. And that's how they can handle such huge amounts of information without getting bogged down by irrelevant details.
Wow, that's incredibly clever. But doesn't this still raise the issue of memory capacity? I mean, even if they're selective, can they really keep adding new information forever?
You're right, there's always a limit to how much any system can store. And that's where Titans have another trick up their sleeve, a forgetting mechanism.
A forgetting mechanism. Isn't that kind of counterintuitive? Why would you want an AI system to forget things?
Well, it's not about forgetting everything. It's more like strategic decluttering.
Decluttering.
Yeah, just like our brains have ways of letting go of less important memories to make room for new experiences, Titans have a built-in mechanism to selectively downplay or erase information that's no longer relevant.
So it's like they're constantly reorganizing their mental bookshelves to make sure the most important information is always within easy reach.
That's a great way to put it. And this ability to dynamically manage their memory is a key part of what makes Titans so efficient and adaptable. They can learn from the past without getting bogged down by it, which lets them tackle even those really tough, long context tasks.
Okay, I'm already super impressed with these Titans. They've got this amazing neural long-term memory that learns to prioritize surprising information. And they even have a way to forget the less important stuff. But how exactly is all of this integrated into the whole architecture? Is it like a separate part of the brain, or is it woven throughout the whole network?
That's a great question, and it leads us to the different flavors of Titans, so to speak.
Flavors.
Yeah, the researchers came up with 3 different ways to incorporate this neural long-term memory, each with its own strengths and weaknesses.
3 flavors of Titans, huh? Okay, now I'm really curious. What are these different approaches, and how do they change the way Titans work?
Well, the first one is called memory as a context, or MC for short.
MC, all right.
In this version, the long-term memory acts kind of like a wise old advisor, whispering insights from the past to help the model make sense of the present information.
So it's like having a built-in historian who can provide background and context whenever the model encounters something new.
Exactly. It's all about enriching the model's understanding by connecting the dots between the present and the past.
Okay, that makes sense. What about the second flavor?
The second one is called gated memory, or MAG.
MAG, okay. And this one is...
This one's a bit more complex, but also super clever.
Oh, I love when things get complex and clever.
Imagine you have 2 different types of memory, one for really precise short-term details, and another for a broader but kind of fading sense of the past.
Okay, I think I'm following.
Well, MAG is kind of like that. It combines the long-term memory with a more focused short-term memory system through a special gating mechanism.
So it's like a detective who can meticulously analyze the immediate clues, but also draw on a vast database of past cases to see the bigger picture.
A perfect analogy.
Nice. All right, so we've got MA, the wise advisor, and MAG, the super detective. What about the third flavor?
And lastly, we have memory as a layer, or MAL for short.
Mal. And
This one takes a more straightforward approach. In ML, the neural memory is integrated directly into the processing layers of the network.
So it's like adding another dimension to the model's thinking, allowing it to consider both the immediate information and its long-term knowledge at every step.
Precisely. And each of these architectural choices, MA, C, MAG, and ML, offers a different way of tapping into that power of long-term memory, and that's what makes them so versatile.
This is already mind-blowing. We've talked about how Titans take on those limitations of transformers, this whole idea of neural networks having different memory systems, and even these 3 different ways to incorporate that neural long-term memory module.
It's pretty fascinating stuff.
It really is. But before we get too carried away, there's one more thing that caught my eye, persistent memory. What's that all about?
Ah, yes, persistent memory. This is where things get even more interesting. Think of it like giving the model a built-in cheat sheet for the specific task it's trying to solve.
A cheat sheet.
Yeah, like if you're training a Titan to analyze financial data, persistent memory would be like giving it a basic understanding of economic principles right from the start.
So it doesn't have to relearn those fundamentals every time. It can focus on the more complex stuff.
Exactly. Persistent memory acts like a foundation of knowledge that stays fixed, even as the model learns from new data.
Okay, so it's a way to make the model more efficient and accurate, especially in complex domains.
Exactly. It's a really clever trick.
This is getting really sophisticated. But I guess the big question is, how do these Titans actually perform compared to the big players in AI? Do they live up to all this hype about enhanced memory and long context understanding?
That's what we'll dive into next, and I can tell you the results are pretty remarkable. Get ready to see how Titans stack up against the heavyweights like Transformers and some of those specialized long context models.
Okay, I'm on the edge of my seat. Bring on the results. Okay, so spill the beans. How did these titans actually do against the competition?
Well, they put them through the ringer, tested them on all sorts of tasks. They started with the classic language modeling challenge.
The language modeling challenge, the one where the AI has to predict the next word in a sequence?
Exactly. And they pitted the Titans against some of the top dogs in that area. Like Transformer plus RetNet, even that fancy gated DeltaNet.
So like a neural network battle royale?
Pretty much. And guess what? The Titans held their own. Across a whole bunch of different benchmarks, they consistently outperformed the competition.
No way. So they were better at predicting the next word.
Yep. And they even managed to do it while being way more efficient, especially when dealing with those super long sequences we talked about earlier.
So they're faster and better. That's pretty impressive. But can they do more than just predict the next word? Can they actually reason and understand concepts like we do?
You're asking the right questions. And the answer is yes, they can. They tested them on some common sense reasoning tasks, stuff like PIQA, HelloSwag, and BullQ. Those tasks where the AI has to figure out everyday scenarios and answer questions that require logic and deduction.
The kind of stuff that used to trip up AI all the time. Remember those early chatbots that would just spit out nonsensical responses?
Exactly. But the Titans, they aced those tests. They showed they could actually grasp basic human logic and reasoning.
Okay, that's a relief. But what about those super long contexts we keep talking about, the ones that make Transformers sweat? How did they fare there?
Remember that needle-in-a-haystack analogy?
Yeah, finding a tiny piece of information hidden in a massive amount of data.
That's the one. Well, they threw the Titans into the deep end with a task called single NIH, part of that ruler benchmark. They had to find specific bits of information buried in increasingly longer sequences, starting from 2,000 tokens all the way up to 16,000 tokens.
16,000 tokens. That's like searching for a needle in a haystack the size of a football field.
It was brutal. And you know what? While most of the models, including some pretty sophisticated transformers, started to fall apart as the context lengths grew, the Titans, they just kept chugging along.
No way they didn't lose their edge.
Nope. They showed this amazing ability to hang on to information and actually use it effectively, even over those incredibly long distances. It's like they have this superhuman capacity for focus and attention to detail.
Okay, that's seriously impressive. But what about those AI systems that are specifically designed to handle long contexts? How did the Titans stack up against those specialists?
That's where things get really interesting. They use this benchmark called Babylon. It's specifically designed to test a model's ability to reason over these huge chunks of text.
Kind of like the ultimate detective challenge for AI.
Exactly. They had to solve these really complex tasks, like piecing together clues scattered across massive amounts of text. Is no walk in the park.
So they were going head-to-head with the best of the best in long context AI. What happened?
The Titans went up against giants like GPT-4, Llama 3, and Recurrent Gemma, models that are famous for their long context skill.
Don't leave me hanging.
The results were pretty shocking. Even with way fewer parameters, the Titans outperformed them all. They achieved the highest accuracy on that super tough benchmark.
Wow, they really are punching above their weight. Efficient, great at language modeling, logical, and they can handle those super long contexts like it's nothing. Is there anything these Titans can't do?
Well, remember how we talked about how Titans use those deep MLPs for their neural memory?
Yeah, deeper networks, usually more powerful, but they can be a pain to train.
Right, there's always a trade-off. Well, the researchers wanted to figure out how the depth of those networks affected both performance and efficiency. So they did some experimenting.
What did they find? Was there a sweet spot?
They found a pretty fascinating trade-off. As they made the memory module deeper, the model got much better at understanding of those long sequences. It was like the deeper memory gave them a better grasp of those long-term dependencies.
So deeper memory equals better long-term understanding. Makes sense. But probably at the cost of slower training, right?
Yeah, that's the catch. But they didn't just stop there. They started exploring ways to make the training process more efficient, even with those deep memory modules. They looked at things like tensorizing the computations and using parallel processing to speed things up.
So they're not just focusing on performance, they're also thinking about practicality. They want to make sure these Titans are actually usable in the real world. That's great to hear. But so far, we've mostly talked about language stuff. Can they do anything else? Can they, branch out beyond the world of text and language?
That's the question, isn't it? Can they handle other types of data? Well, the researchers decided to find out. They took the titans beyond the realm of language and applied them to two very different domains: time series forecasting and DNA modeling.
Time series forecasting and DNA modeling. Wow, talk about a change of pace. From understanding text to predicting the future and decoding the secrets of life itself.
It's pretty wild, right? So, for the time series forecasting, they took that neural memory module and incorporated it into this framework called SIMBA.
Simba.
Yes, SIMBA. It's designed to predict future trends based on historical data.
So, like predicting stock market movements or figuring out weather patterns.
Exactly. And just like with those language tasks, that neural memory module gave SIMBA a major performance boost. It was really good at picking up on those long-range dependencies that are so important in time series data.
So, the Titans can predict the future, or at least the future of patterns in data.
Right. But then they took it a step further with DNA modeling. They used the titans to classify different types of DNA sequences.
Wait, so they were teaching AI to read the language of life. That's incredible. But could they actually achieve anything meaningful in such a specialized field?
They could, even in that totally different domain. The neural memory module proved its worth. It actually achieved results that were comparable to some of the most sophisticated DNA modeling architectures out there.
So it sounds like these titans are shaping up to be a real game changer. They're not just stuck in the world of language. They could revolutionize all sorts of fields: finance, meteorology, even genomics. What's their secret? Why are they so successful?
Well, to get to the bottom of that, the researchers did a bunch of what are called ablation studies.
Ablation studies.
Yeah, they basically took the Titan's architecture apart, piece by piece, to see which components were really driving its performance.
So, like a scientific detective story, eliminating suspects one by one until they find the real culprit.
Exactly. And what they discovered is that every single element of that Titan design was playing a crucial role. Everything from the deep MLPs and the memory module to that forgetting mechanism we talked about, even the addition of persistent memory, it all worked together perfectly.
So it's not just one magic ingredient, it's the whole recipe that makes Titans so powerful and versatile. Wow, this has been truly mind-blowing. These Titans are pushing the boundaries of what AI can do. But there's got to be more, right? There's still so much to unpack here. What other juicy details are hiding in this research? There's one more really cool thing about this Titans research we haven't gotten to yet.
Oh yeah, they did something pretty interesting.
Instead of just looking at the results, how well the Titans performed on those tasks, they actually dug deeper.
Right, they wanted to understand what was happening inside those Titan models, like how they were actually doing it.
It's like they were trying to read the AI's mind, figure out its thought processes.
Exactly. They used this technique called probing to take a peek inside the neural long-term memory, see what kind of information the model was storing and what it was focusing on.
So they were like AI archaeologists, digging up those memories buried deep within the neural networks. What did they find? Any big surprises?
Oh, definitely. One of the coolest things they found was that the Titans seemed to be creating their own internal representations of the data. And these representations were surprisingly similar to how humans organize information.
Wait, are you saying that Titans are starting to think like us?
It's a fascinating idea, isn't it? It's like they're developing their own kind of common sense.
Give me an example.
Well, when they probed the Titans that were trained on language tasks, they found that the models were grouping words and concepts together in ways that mirrored human semantic categories.
So they weren't just memorizing random strings of words, they were actually understanding the relationships between those words, building their own mental maps of meaning, kind of like their own internal dictionaries.
Precisely. And this wasn't just happening with language. When they probed the Titans trained on time series data, they found that the models were forming these internal representations of temporal patterns, almost like they were creating mental timelines of events.
So they weren't just predicting what might happen next, but also when it might happen based on those past patterns. That's pretty wild.
It is. And it suggests that these Titans are doing something much deeper than just crunching numbers and spitting out results. They're building their own internal models of the world, and those models are surprisingly similar to our own. It opens up all sorts of crazy possibilities for the future of AI.
Speaking of the future, this whole deep dive into Titans has been incredible. We've gone from the limits of transformers to the weird world of AI memory, from all those innovative architectures to some truly mind-boggling results. It's clear that Titans are a major leap forward. But where do we go from here? What's next for the Titans and for AI as a whole?
Well, the researchers are already looking at ways to make these Titans even bigger, even more powerful.
So, titans on steroids, what kind of problems could those super titans tackle that are just impossible for us right now?
Imagine titans that can analyze the entire internet archive, find those hidden connections and insights that we'd never be able to spot, or titans that can track global climate patterns in real time, help us predict and maybe even prevent the worst effects of climate change.
Those are some pretty epic possibilities. But as with any powerful technology, there are always those ethical concerns, the potential risks we need to consider. What are some of the things we should be thinking about as we venture further into this brave new world of AI?
That's a really important point. As we create these increasingly powerful and independent AI systems, we have to be incredibly careful. We have to make sure they're aligned with our values, that they're transparent, accountable, and that they're used for good, not for harm.
It's not just a technical issue, it's a societal one. We need to have those open and honest conversations about what kind of future we want to build with AI. We need to work together to come up with some rules, some safeguards, to make sure these powerful technologies are used responsibly.
I couldn't agree more. The future of AI isn't set in stone. We get to shape it.
Wow, this conversation has been mind-blowing and humbling. Titans are this incredible example of how far AI has come, but they also show us how much we still have to learn and think about as we keep developing these technologies.
An exciting time to be alive, that's for sure. We're on the edge of this whole new era of AI, and the Titans are leading the way.
Well said. Thanks for joining me on this wild ride into the world of Titans. And until next time, keep exploring, keep asking questions, and keep your minds open to all the possibilities of AI.
It's been a pleasure being here. And to everyone listening, stay curious out there.